Okay, welcome back to another video on the Maths channel. It's your teacher, Mr. Lim here. In this video, we're going to be looking at the second lesson of the Year 12 advanced topic, motion and rates. So lesson 2 is the velocity and acceleration as derivatives. So by the end of this lesson, you'll be able to calculate velocity and acceleration as derivatives. Please be, be aware of all the different notation that we use. So displacement is equal to x, or x in terms of t. So depending on how many seconds it is, where is it located. Velocity is v, which can also be denoted as dx dt. So we're differentiating displacement with respect to time. And it can also be written as x dot. Acceleration is the second derivative, so d2x dt squared. Or we can say it's the first derivative of velocity, so dv dt, or x double dot. Okay, so I will not usually use dv dt, but I'll usually use the rest. Okay, all right, so let's have a look at the first example. Here again is the displacement time graph of the ball moving with equation x is equal to 5t, bracket 8 minus t, where t is time in seconds. And we'll say x is in meters. Differentiate to find the equation for the velocity v. Draw up a table of values at 2-second intervals and sketch the velocity time graph. Maybe I'll get you to pause the video, see if you can have a go with A. If not, just continue watching. Okay, so the first thing I would do is I would expand the brackets to give me 40t minus 5t squared. And now I will differentiate this. So velocity is pretty much just x dot. So I'm going to differentiate this with respect to t, giving me 40 minus 10t. Right, we're now going to draw up a table of values at 2-second intervals and sketch the velocity time graph. So we know when we look at the original function here that there are zeros at t equals 0 and at t equals 8. So I'm just going to go from 0 to 8. Actually, we want to do it for velocity, so not x, I'll do it for v. 0, 2, 4, 6, and 8. Okay. So let's input this into a calculator. Velocity is 40 minus 10 answer. So 40, 20, 0, minus 20, minus 40. Okay, so we've differentiated, drawn up the table of values. We now need to sketch the velocity time graph. So let's sketch this. Okay, so we've got velocity, not velocity, that's time. This is my velocity. 2, 4, 6, 8. We know we've got 0 here. And the velocity goes from 40 to negative 40. So I'll just say that's 20, 40, negative 20, negative 40. Okay, so we can see that this is a straight line because with a constant gradient of negative 10, right? It's not a quadratic. So, and that's my velocity time graph. Okay, make sure you write the v here. That's really important. Question B. Measure the gradients of the tangents that have been drawn at A, B, and C on the displacement time graph and compare your answers with the table of values in part A. So A is here, so it's already given us the tangent. So I'm just going to maybe draw that right angle triangle in. That's going to help me. So I know that it has a rise of 40. It has a run of 2. So we can see that the gradient at A will be rise over run, which is 20. Well, A is at t is equal to 2. T equals 2, it says the gradient is 20. So that's good, right? The gradient at B, well, we can see here that if we were to draw a tangent, because that's a stationary point, the gradient is just going to be 0. And B is at t equals 4, and according to our table of values, t equals 4, the gradient is 0, which is correct. And the gradient of C, so the tangent's already drawn for us, so I'll just draw my right angle triangle according to that. We can see here that it has a rise of negative 40, because it's going down, and a run of 2. So negative 40 on 2, which is negative 20. C is at t equals 6. At t equals 6, velocity is negative 20, or gradient is negative 20. So that's good. Alright. Question C. With what velocity was the ball originally hit? So originally, initially, that means t equals 0. So at t is equal to 0, the velocity was 40. Okay, so I'm going to write, therefore, at 40 meters per second. Alright, so whenever we're doing velocity, always, or any of these, displacement, velocity, acceleration, always put in the units. Okay, so displacement will be, whatever distance it is, like meters. Velocity is the speed, so meters per second. Acceleration, meters per second squared. Okay, so just be careful with those. Alright, and question D. What is its impact when it hits the ground? Okay, so basically we want to know impact speed, which is the velocity. It hits the ground, so when x is 0, because that's the ground, hits the ground at t equals 8. So at t is equal to 8, we can see that the velocity is negative 40 meters per second. And because the question is asking for speed, and we know speed is the magnitude of velocity, therefore impact speed is positive 40, right? Because we can't have a negative speed. 40 meters per second. Alright, let's have a look at vector and scalar quantities. So displacement and velocity are vector quantities, meaning that they have direction built into them. In the example above, a negative velocity means the ball is going downwards, and a negative displacement would mean it was below ground level. Distance and speed, however, are scalar quantities. So distance is the magnitude of the displacement, and speed is the magnitude of velocity. And neither can be negative. So it's important that distance and speed cannot be negative. Alright? Example 2. A particle moves so that its distance in meters from the origin at time t seconds is given by x is equal to 1/3 t cubed minus 6t squared plus 27t minus 18. Find the velocity and speed when t is equal to 4. Okay, so notice how they look similar, velocity and speed. But remember, speed can't be negative. Okay, so if velocity is negative, we need to absolute value it. Alright. So we need to find velocity. We are only given displacement, so we need to differentiate with respect to time. So when we differentiate this, we'll get t squared minus 12t plus 27. Okay, so when t is equal to 4, we can see that the velocity is equal to, so we'll just put it in our calculator. Answer squared minus 12 answer plus 27 minus 5 meters per second. Alright, so just remember, in meters, t seconds. Right, so meters per second. Well, if velocity is negative 5, that means it's going down at a speed of 5 meters per second. Alright, so we've done A and B. Sorry, we've done A, velocity and speed. Question B. Find the times when the particle is stationary. Okay, so stationary, think about it as the stationary point. The first derivative is equal to 0. Here, the first derivative is velocity. Okay, so stationary means not moving. Not moving means velocity is 0. Okay, when v is equal to 0. So I'm just going to sub that in. T squared minus 12t plus 27. I'm now going to factorize this. So that's a mnemonic t minus 9t minus 3 is equal to 0. Therefore, t is equal to 9 or 3. Therefore, stationary at 3 seconds and 9 seconds. Okay, seconds because here the question tells us seconds. And question C. Find the distance from the origin at these times. So, distance is x. Okay, we want displacement. So when t is equal to 3, what is x equal to? Okay, so we know that x is this. So I'm just going to sub it into that. So 3. We've got 1/3 of answer cubed minus 6 answer squared plus 27 answer minus 18. 18. And when t is equal to 9, the displacement is minus 18. Okay. So what that means is the first one, because it's positive, it just means it's 18 meters to the right of the origin. Okay, or, to the right of the origin. And here we've got minus 18, which means it's just 18 meters to the left. Okay, so therefore, t equals 3 and t equals 9. Particle is 18 meters from the origin. Because the question is only asking for distance, it's not asking for displacement, so we don't need to worry about where in comparison or relative to the origin the particle is. Alright, example 3. Consider again the ball moving with displacement function x is equal to 5t bracket 8 minus t. Find the velocity function v and the acceleration function a and sketch the acceleration function. Alright, why don't you pause the video and have a go with this one. Alright, so first thing is we're going to expand, because it just makes it easier to differentiate. We know velocity is x dot, so we're going to differentiate displacement with respect to t. And we know acceleration is x double dot, so we're going to differentiate velocity with respect to t, minus 10. Okay, so we found the velocity function, we found the acceleration function, we need to sketch the acceleration function now. So because it's minus 10, so this is my t, this is my acceleration, minus 10 is down here, and so it's just a constant, so it's just a horizontal line. Alright, question B. Find and describe the displacement, the velocity, and acceleration when t is equal to 2. So when t is equal to 2, we can see that the displacement is equal to, I'm just going to sub it into this one, and then sub into that one, and sub it into that one, which we can't. But we'll do the first one. So we've got 2, 40 answer minus 5 answer squared, 60. We know velocity is equal to 2, 40 minus 10 answer, 20. acceleration is just minus 10. Okay, so what does this mean? Okay, x is equal to 60, that's 60 meters. V is equal to 20, that's 20 meters per second. And acceleration is minus 10, so that's minus 10 meters per second squared. So it's 60 meters above ground level. Okay. It's moving up because it's positive, so it's a positive direction. So moving up at a speed of 20 meters per second. There's a 1 there. And this is accelerating at a rate of 10 meters per second squared downwards. Okay, and you should realize that that's actually gravity, okay, which is 9.8, so very close to 10. Alright, C. State when a ball is speeding up and when it is slowing down, explaining why this can happen when the acceleration is constant. So I think it might be helpful for us to have a look at drawing the velocity time graph. And the reason why is because we want to think about velocity. Okay, velocity. When is it speeding up and slowing down? So I'm going to draw time graph. Actually, I might do it over here. Time and velocity. So I'm going to draw this. Okay, 40 minus 10t. Okay, so let's just do it 2, 4, 6, and 8. When t is 0, we know that the velocity is 40. When t is 2, that's 20. Okay, and 0, minus 20, and minus 40. Okay. So what you should realize is that even though this is above the t-axis, right, x-axis, t-axis, that means the ball is actually going up. Okay, it's actually going up, but it's slowing down because the velocity is slowing towards 0. Okay, so it's going up, but it's slowing down, and then it's going to speed up in a downwards direction. So for question C, we can see here that between 0 and 4, we can see that the velocity is greater than 0. And maybe we can do that over here as well, 2, 4, 6, and 8. Between 0 and 4, the acceleration is minus 10. Acceleration is negative. So because they're opposite, we can see that it's going up because velocity is positive. So ball is going up, but it's slowing down because that's negative. By 10 meters per second every second. Okay, and it's slowing down because these symbols are opposite. They're not the same. Okay, but between 4 and 8, we can see that velocity is negative, so it's less than 0. And acceleration is negative as well. So it's going down, and it's also the acceleration is also downwards. Therefore, the ball must be speeding up. Okay, therefore, ball is going down and is speeding up by 10 meters per second every second. Right, I hope that makes sense. If you want to think about it, you can draw the displacement graph. So we know that this displacement graph, it goes up to 80 and it comes down. Okay, so we can see it here that this part, velocity is positive, that means it's sloping up. Right? It's sloping up. But we can see here that because it's concave down, that's acceleration is negative. Concave down. Second derivative is less than 0. Therefore, it has to be slowing down. And here we can see velocity is negative, which means it must be sloping down, which when we draw the tangents along the displacement curve, it is sloping down. And it's also concave down still, that's why acceleration is negative. Okay? Alright, example 4. Consider the function x is equal to 1/3 t cubed minus 6t squared plus 27t minus 18. Find the acceleration function and find when the acceleration is 0. And where is the particle at this time and what is its velocity? Why don't you pause the video and have a go with this one. Right, question A. Find the acceleration function. Oh, that means we need to differentiate. So, I need to differentiate twice because when I differentiate x, I'll get velocity. When we differentiate that, we'll get t squared minus 12t plus 27. And when we differentiate it a second time, acceleration is 2t minus 12. Find when the acceleration is 0. A is equal to 0. 2t minus 12. 2t is equal to 12. T is equal to 6. Okay, therefore, acceleration is equal to 0 when t is equal to 6 seconds. Okay, we always assume, if it doesn't tell us, always assume x is meters, t is in seconds. And question B, where is the particle at this time and what is its velocity? So at t is equal to 6, okay, so at this time, t is equal to 6. So where is it? That's displacement. What is velocity? That's v. Okay, so x is equal to, just sub it in. All right. Zero, so it's at the origin, and velocity is equal to s squared minus 12 answer plus 27 minus 9. Okay, so therefore particle is at the origin, moving at a velocity of 9 meters, I can write properly, 9 meters per second. Sorry, minus 9. Okay, a velocity of minus 9, so it's moving to the left. Alright, let's have a look at some trigonometric equations of motion. Example 5. A particle's displacement function is x is equal to 2 sine pi t. I might just put that in brackets so we know that the whole thing there is the angle. Okay, sine of the angle pi t. Find its velocity and acceleration functions and graph all three functions in a time interval from 0 to 2. Why don't you pause the video, have a go with A, B, C, and D. Alright, question A. So we've got the displacement is equal to 2 sine of pi t. So velocity, we need to differentiate. Now here we've got sine of some function. So just to refresh our memories, if we go back to our reference sheet, and we've got sine of f of x. When we differentiate that, we get f dash of x cosine of f of x. So we change the sine to cosine, we write exactly the same thing next to it, but at the front we need to differentiate whatever is in the angle and bring that out to the front. So we have a look at here. This is our angle, and because we're differentiating with respect to t, not x, when we differentiate pi t, we get pi. So I'm going to bring that out to the front with that 2 pi. My sine will become cosine, and then the angle will stay the same. To get acceleration, we differentiate a second time. Again, we need to differentiate pi t with respect to t to give us pi. So we bring that out to the front, and we get 2 pi squared. When we differentiate cosine, we actually get negative sine. Okay, so we look back here. When we differentiate cosine, we get negative sine. Okay, so negative we'll bring out to the front, right? Maybe I'll just rewrite that, minus 2 pi squared sine of pi t. Alright, so we found the velocity, we found the acceleration functions. Now we need to graph all three in the time interval from 0 to 2. So maybe I'll do that over here. Okay. When we looked at how to graph trig functions, remember we worked out that whatever is at the front, the coefficient of sine or cosine or tangent, that was the well, sine and cosine, that was the amplitude. So we know that it's going to go up to 2 and down to negative 2. Okay, because the center of motion is just 0. So it's 2 above and 2 below 0. And we also worked out the period. So I'm just going to call this x for displacement and t for time. We know that period, because it's sine, we know the normal period of sine is 2 pi, but then we divide it by the coefficient of x, in this case the coefficient of t, which is just 2. So that's perfect because we want it in this domain from 0 to 2. 2, 1, half and 1 1/2. Okay, so remember we always split each period into 4 equal parts because that's going to give us our graph. So we're going to graph this sine curve. So it's going to go from 0 to 2, back to 0, down to minus 2, back to 0. Okay, and that's our displacement graph. For our acceleration, sorry, not acceleration, velocity. Let's do velocity next. This time, the amplitude is 2 pi. Our center of motion is still 0. So we're going to go up 2 pi and down to negative 2 pi. And again, the period is just 2 pi over pi, which is still 2. So 2, 1, half, 1 1/2. And now we're just going to draw the cosine curve. Now, the cosine curve we know always starts at the top. Right, so it usually starts at 1, instead of 1 is 2 pi, so it's going to start here, come down to 0, down to negative 2 pi, back to 0, to 2 pi. Okay, that's our velocity, and our acceleration. This time, the period is minus 2 pi squared, or we can just say 2 pi squared. So I'm just going to say that's 2 pi squared minus 2 pi squared. And the period, again, is just 2 pi over pi. Okay, 2 pi because the normal period of sine and cosine is 2 pi. So we're dividing 2 pi by the coefficient of t, which is just 2. All right. Now, because of this negative symbol here, it's not the normal sine curve. We're just going to, well, it is a normal sine curve. We're just going to flip it. We're going to reflect it across the t-axis. So instead of going up like normal, we're going to go down first. So I'm going to go down, then up, then back down. So it's going to look like this. Right, and that's my acceleration curve. Alright, so that's question A done. Question B. Find the times within the time interval from 0 to 2 when a particle is at the origin, and find its speed and acceleration at those times. So when is it at the origin? Well, origin is when x is 0. Okay, so particle is at the origin at t is equal to 0, at t is equal to 1, and at t is equal to 2. Okay, 0, 1, and 2. Find its speed and acceleration. Okay, so we still need to do speed and acceleration. So we can see here, we can work out the velocity of each of these. So at t is equal to 0, the speed is 2 pi, or velocity is 2 pi. At t is equal to 1, velocity is negative 2 pi. And I might write meters here and meters per second. And at t is equal to 2, sorry, meters per second, that's right. Velocity at t is equal to 2, velocity is 2 pi meters per second. Alright, and acceleration. Okay, at t is equal to 0, acceleration is 0. At t is equal to 1, acceleration is 0. At t is equal to 2, acceleration is 0. Okay, now the question says speed, not velocity. So we can see here that the speed is just 2 pi for all of them actually. Okay, at t equals 1, the velocity is negative 2 pi. That just means it's going left. Alright, and that's it. Alright, question C. Find the times within the interval from 0 to 2 when the particle is stationary, and find its displacement and acceleration at those times. So we know it's stationary at v is equal to 0. So when the velocity is 0, it's not moving. So velocity is 0 here and here. At t is equal to half and t is equal to 1.5. Alright. Find its displacement. So that's x. And find its acceleration. So at t is equal to half, the displacement is 2. At 1.5, displacement is negative 2. At t equals half, the acceleration is minus 2 pi squared. So I might write meters here. And minus 2 pi squared meters per second squared. And acceleration 1.5. Okay, so I'm looking at the acceleration graph. 1.5 is 2 pi squared. Positive 2 pi squared meters per second squared. Alright. And question D. Briefly describe the motion. So this is question D down here. So you can see here that the particle oscillates forever between x is equal to minus 2 and x is equal to 2. Okay, so between x, so that's this one, minus 2 and 2. It just keeps going between these two. With the period of 2, it starts at the origin, moving first to x is equal to 2. Okay, so if you want to think about this as the particle oscillating from left and right, it starts at the origin and it goes right first, and it goes left to minus 2, and then back to 2, and then back to minus 2 forever. Okay. Let's have a look at motion with exponential functions. So sometimes the question will ask what happens to the particle eventually, or as time goes on. That simply means taking the limit of the displacement and the velocity as t approaching infinity. Example 6. A particle is moving so that its height x meters above the ground at time t seconds after time 0 is x is equal to 2 minus e to the negative 3t. Find the velocity and acceleration functions and sketch the 3 graphs of displacement, velocity, and acceleration. All right, question A. So we can see here displacement is 2 minus e to the negative 3t. So velocity, we're going to differentiate this. The 2 will disappear. When we differentiate this with respect to t, we'll get minus 3. So I'm going to bring that down to the front. That negative will cancel out, so it's going to give us positive 3. E to the minus 3t. Okay, remember the power stays the same. Acceleration. Again, we're going to differentiate the power. That's going to give us minus 3. 3 times minus 3 is minus 9. E to the minus 3t. Alright, so we found the velocity and acceleration functions. We now need to sketch the 3 graphs. Now, the best way, or the easiest way for me to do this is probably to do a table of values. So I'm just going to do a table of values, displacement, velocity, and acceleration. Okay, we'll do that when t is 0, 1, and 2. I think that should be enough for us to determine what we need to graph. So we'll do 0 first. We'll do displacement. We've got 2 minus e to the negative 3 answer. This one. What about when when t is 1, we get 1.95. When t is 2, we get 1.998. Okay, so it's pretty obvious that it's approaching 2. Right, what about velocity? We'll do 0 first. 3 e to the power of negative 3 answer. 3. Then t is 1. 0.15. When t is 2. 0.007. Okay, so here it's pretty obvious that it's approaching 0 as t approaches infinity. And acceleration. We've got minus 9 e to the power of negative 3t. E to the power of negative 3 answer. Minus 9. Negative 0.45. About 2. Negative 0.022. So again, we can see that as t approaches infinity, a will approach 0 just from below, okay, because it's from negative. So now that's going to help this graph. Alright, so we'll do the displacement. T, x. Alright, so when it's 0, we've got 1. And we can see here that it's approaching 2. So I'm just going to put 2 here. And we know it's going to approach 2. Might see if I can make it a little bit more exaggerated. Okay, approaching 2. So that's my displacement graph. Velocity. It starts at 3, and then we can see here it's approaching 0. And acceleration starts at -9, then it's approaching 0. Okay. All right. Question B. Find the initial values of displacement, velocity, and acceleration. So we actually have it here, because initial just means when t is equal to 0. Right? When t is equal to 0, we've got them all here. So when t is equal to 0, displacement is 1 meter, right? Because here we've x meters, t seconds. Velocity is 3 meters per second. Acceleration is -9 meters per second squared. Question C. What happens to the displacement, velocity, and acceleration eventually? So we can see here, as t approaches infinity, x approaches 2. Okay, we can see that it's approaching 2. Velocity approaches 0. I might write 2 meters, 0 meters per second. And acceleration will approach 0 as well, meters per second squared. And last one, briefly describe the motion. Alright, let's do that down here. So what's actually happening? It might help to look at the graphs to see what's actually happening. I personally prefer to just look at the displacement graph to see what's happening to it. So we can see that the particle starts 1 meter above the ground. Okay, because this one says 6 meters above the ground. With initial velocity, so that's when t is equal to 0, which is 3 meters per second. But we can see here that it's constantly slowing down because the gradient is getting flatter and flatter and flatter. So it is constantly slowing down. Which is why we can see here that acceleration is approaching 0 because the gradient, or actually the velocity is approaching 0 because the gradient is approaching 0. So it's constantly slowing down as it moves towards a limiting height of 2 meters above the ground. Okay, we can see that in the displacement graph. It's approaching 2 meters above the ground. All right. I might pause the video here, and I'll just make part 2, which involves these HSC style questions. All right. If you found this video helpful, please give it a like and subscribe, and I'll see you in the next video.